looking at this question here, and it's a tricky one because when we first just glance at this scatter plot, we see a straight line, and that's going to be a distractor in this case because we really need to read what it says here, what's on the y-axis. Y-axis is change in hundreds of cookies from previous day. And here's the number of days. So day 1, 2, 3, 4, 5, 6, 7, 8. And let's read to try to help us understand this. It says, at a bakery, the number of cookies baked each day changes based on anticipated demand. The scatter plot shows the change in hundreds of cookies days baked from the previous day for 8 days. So it tells us 2, 5, this point up here, means on day 2, the number of cookies baked will be 500 more than the number of cookies baked on day 1. A function model C is to be constructed for the number of cookies based on each day. But that's not what we see here, right? That's to be constructed, not what we see. So which of the following statements best supports the selection of model C? We don't actually have to make the model for C. We just need to know, basically, we have to be able to pick from these choices. It says, based on the information of rate of change is roughly linear, a linear model is best. Now, let's think about that. If this is the distractor, right? Because we see this line and then we pick choice A and we get it wrong because we're too quick, we're not thinking. This is a linear model for the change in. If I had a linear model for my model, then when I found, so if this was my model, then the rate of change is basically the same. So it's some value, like let's say we go down 3/2. So 3/2 would be 1.5. So my graph here would just be a straight line at 1.5. So it can't be A because A is not, this is showing the change in and not the actual model. So it can't be that. And I'm going to jump to D because it can't be D because D is a piecewise linear model, which the piecewise makes a bit of sense if we say we have to only deal with full days, but it's not linear, so it can't be D. So that means that B, because the information of rate of change is roughly linear, a quadratic model is best. Because the information of rate of change is positive and negative, a quadratic model is best. So both of these are predicting a quadratic model. And a quadratic model makes sense because I have Desmos up here. I just have, this isn't the model, this is just a quadratic. But a quadratic model is gonna, if I took the rate of change between let me change this so that I get a step of 1. Right? If I took a rate of change between 1 and 2, right? Sylvia, we know. Sylvia, stop. I know, stop. And I take the rate of change between 2 and 3 by always having this same thing, I'm going to end up with a linear data point here, right? And not exactly linear, but the rate of change is going to roughly be linear between those points. Now, B is the better answer because that is a true statement. C is not the better answer because although I could, because I'm only dealing with days 0 through 8. So although I could have 0 through 8 have a down part and an up part, I don't necessarily have to have that, right? It could be a quadratic model just by dealing with one side of it. So I don't have to be dealing with both sides of the quadratic model to have a quadratic be the best model. And that's why B is the best answer. And this brings us to one of our most important things about multiple choice, is it's always choosing the best answer. And in this case, that's choice B.